Good morning. Thank you for joining the webinar on how to model a compressed hair network from production point of views, co-organized by BIM&CO and Parker Transair. We will take 30 minutes to show the presentation and the live demo of the solution we have co-developed together. And you will have several questions during this webinar. We invite you to answer. It's a very quick form, and we also will take a few minutes at the end of the session for a question and answer session. I am Vincent Berlioz, in charge of development and partnerships for BIM&CO, and we'll organize this session together with Gael.
When it comes to me, so my name is, you want me to start now, Vincent?
Yes, sure, you can start.
Okay. So as for me, so my name is Gael Le Carrère. I'm French and based in France, and I'm working for Parker Transair, and I've been for 6 years now. And I'm part of a team called the Project Support Team, which is helping our customers with their industrial fleet project through design and sizing of installation, technical question and other matters, drawings, quotation, bill of material, etc. To start this webinar, first a presentation of who we are. So Transair, who we are. We are a manufacturer, and we are a manufacturer of modular aluminum pipe system. What do we mean by that? Aluminum because our technology is using aluminum pipe, and modular because we are having connectors with quick connections to do the connection in between the piping. Transair exists since 1996, so we've been on the market for more than 25 years now, and we are a made in France product. When it comes to our DNA, I would say, Transair wants to offer the best compromise between first, safety. Safety is really what's most important for us. Safety of the person which are going to install our system, but also the person which are going to use it after. And second, rapidity on modularity with the use of our quick connection technology. Also, we want to have a technical added value on the project with the support of the team. I'm part of the project support team. When it comes to our specification, so Transair can be used to transport 3 types of fluid, I would say. First, we will have compressed air up to a maximum working pressure of 16 bar. So compressed air, it's used mainly for tooling, blow gun, but also a whole kind of machine within the industry. And then we'll have vacuum up to 1 millibar in absolute pressure. So this is what we call industrial vacuum. And there we will find, for example, vacuum packaging process or heavy parts handling. Last, we will have natural gases up to 16 bar, once again. And there, as natural gases, we will mainly have first argon and its mixes with welding process, for example, and then nitrogen with inerting process through the food and bev industry. When it comes to our diameters, so Transair offers a large range of product and diameters from 16.5 millimeters up to 168 millimeters, which allow us to be able to make a project from the technical room with our biggest diameters up to the point of use with our smallest one. Now we'll leave it to you, Vincent.
Thank you, Gael. So same for us. Who is BIM&CO? First of all, we are part of a group called Trace Group, software editor created more than 30 years ago. We are now more than 250 people, generating more than 20 million of revenue in Europe. We are doing many things from electrical calculation, PV calculation, energy management, or LCA analysis. And for BIM&CO, we have been created more than 6 years ago now with the mission of delivering technical content from manufacturers into digital processes, so basically into BIM models now. And to go deeply into what BIM&CO is doing, we strongly believe data should be in the heart of these processes, these data exchange processes. So we really focus on the quality of the product information we share to the market. So every data available on BIM&CO.com, which is what you can see from the iceberg, a marketplace of product informations from manufacturers. These data should be always compliant with market standards, norms, but also project and users' needs. This is why we have developed our technology of connecting the information from manufacturers with the needs from the market. It enables us to facilitate the management of the level of information, so manufacturers can share and users can access the right information at the right time in the right format. If you need, for instance, thermal information, specifications, or maintenance information, you can just select what you need when you download the product data. So basically, this information is quite easily accessible from our web portal, BIM&CO.com, or the private platform called OnFly.io, but also available directly into the designer's workflows through a Revit plugin. So you can directly download from your project the product data from manufacturers, helping users to easily connect with manufacturers' information and manufacturers to boost their visibilities and be directly integrated into users' projects. Gael, I think it's time for you to do your magic.
Okay. Okay.
Maybe we can remove the video.
Yeah, exactly. We will be switching off our cameras just to optimize the data flow. So before heading to Revit and start some modeling, first I would like to have to give you a brief overview of our template and families, so you have a better understanding of what's going on. So all parts of our 3D aluminum range have been designed within the Revit environment. When it comes to our family, so our families are divided within 3 categories inside the Revit. First, we will have pipe fittings. There you will find elbows, T's, cross, connectors. When it comes to fittings, you will have one family associated with one type following a table. And that table will dictate which diameter needs to be used on each case. Second category, pipes. There you will find each of our pipes in each color, so blue, green, and gray in every diameters, so from 16.5 millimeters up to 168. And last, pipe accessories, where you're going to find all the rest, I would say, with valve, quick bracket, wall bracket, but also flanges and our different threaded parts. There, compared to the fittings, you will have, once again, one family, but this family will have several types regarding on the diameters that needs to be used. So no table used on the accessories. So each of our families have its own 3D model, its parameters, and within the templates, you also have the routing preferences, which are going to allow each families to work together as one. So the template is available for free on BIM&CO's website. So you only need to go on their website, register yourself. So this is for free. You just need to create an account, and then you can download as much object and family as you want. Now let's switch within Revit. So here, the goal, so before talking about the project, let's continue that brief overview of the families. So if we go within the project browser, you can see pipe accessories. So each name of the families are in English because the template is designed to be used for everyone within Europe and in the world. So family names are in English, and when it comes to accessories, so you can see one family is several types, and the types correspond to the part number of the object, and that part number is the same as the one inside our catalog. So there is some kind of I would say that. So the template and the catalog, they're on the same page. They're using the same part numbers. So pipe accessories, then we can see pipe fittings with one family and only one type this time, calling a table. And last pipes with the 3 colors. And if we check the properties of the pipes, you will find the routing and preferences configured within the template. So today we are here to design a compressed air network within an industrial building. So here, what I wanted to do with that webinar is to speak about all the mistakes and error we have been able to see within models or feedback that we received from our users, in order to give you the best advice, the best tip and tricks to use the templates in a correct manner and in an optimal one as well, in order to have your network, which is going to be good from a Revit point of view, but also good from what will be installed on site. To speak more about the project, so we will be realizing the compressed air network within that industrial building. So what I did as a starter, so I did create a new project using our template. So new project and select the Tronder template. And within that template, I did link, within that project, I did link 2 models regarding the building. First one, an architectural model using with all the walls and windows and so on. And the second one, having all the HVAC parts, so piping, etc., etc. So this will give us the base and a better understanding of what's going on within the model. To speak more about the work we're going to do today, so I will switch to a floor view. So this is a floor view of the building. The part of the building which is going to interest us most today is going the top part. You can see already other networks that have been designed in the HVAC model. And today we're going to be designing the compressed air network in a space in between those pipes. The network is going to run here on this top part. And the compressor room, the technical room, will be coming from here, from that corner here, and is located at the level 1. So this building has 2 levels, so level 0 and level 1. The network will be at level 0 here on the top part, and the compressor room will be here on level 1, on the level 1 level. So first we'll be designing the technical room, then we'll switch to the network, and we'll finish with a couple of drops, just for you to have a good idea of how we model the complete compressed air network. To speak about the compressor room, so let's have a 3D view of it. So here I am at level 1, as I was saying. I already have my compressors and receivers. So today we will be connecting the compressor and the receiver together, and we will be also, creating a bypass on the receiver. As you can see, my compressor and the receiver already also have the connectors, diameter 50 millimeter. When it comes to designing compressor room, the most important things to know is that you can't plug directly our pipes inside the machine. As I was saying, Tronder, it's a quick connection technology. So you need a part that is going to be the link in between our piping and the standard thread. That part, that family, this is what we call a male stud, and it's going to be found within the project browser in the pipe accessories category. Part number 6605, so here, male stud fitting. And what I recommend you to do when designing your compressor room is to first connect those male stud on your machines. And once this is done, you can connect your machine in between them. To connect this male stud fitting, 2 methods, I would say, 2 main methods. I will switch to a floor view of the compressor room. First method, this is what I would call a quick hook, a quick grip method. I'm not sure how to say it in English. If I'm using I'm taking my object here, my family, as you can see, my male stud is linked to my mouse. And if I approaching my connector, my male stud fitting through the connectors of the compressor room, we can see in the switching side, so going from horizontal to vertical. This is because if I'm putting my male stud Right now, inside my model, Revit will automatically connect it to the connector of the compressor room. So how is this possible? This is because the compressor, it is set as a mechanical equipment. So not special equipment or generic model, but if you set your equipment as inside the category mechanical equipment, you will have that quick grip allowed. So if I'm closing in my mail stud next to the connector of the compressor room, I'm placing my mail stud, and you can see the mail stud appearing and being directly connected on the compressor. So it really helps time and makes things a lot more easier. If I switch back to my 3D view, let's change side a little bit. We can see that if I move my compressor, the mail stud is also moving with it. Now let's switch back to our floor view. Second method, a more classical one. So we're gonna first place our mail stud within our view. So placing them manually from the project browser. I'm gonna turn this one 180 degrees so it's facing the right side. Then I will align my mail stud on the connectors of my receiver. So I'm aligning both of them. And now if I'm switching to a side view, so I will be switching to the side view you can see here, so which is going to give me a nice look of what's going on. Switching to the side view, we can see the mail stud here at level 1, on the level Z1, but elevation 0. I can take my mail stud on the connector of the threaded part and bring it to the connector of my receiver. And as you can see, when they are both at the same location in the model, you have that red, not red, pink, and pink circle and pink cross in each other. If I place the mail stud right now, the connection will be made in between the mail stud, so my accessory, and the receiver. I can do the same for the outlet, placing it, and you can see that in a matter of seconds, I've got both my mail stud connected to my receiver. Something for you to know as well when it comes to compressor rooms, so little things to know. Receivers that are located right after compressors, the inlet is always at the bottom and the outlet always at the top, for you to know. Once we've connected our mail stud, our accessories on our equipments, I would say the hardest part is done. Now we only need to connect them to each other. So I can go on my mail stud, right click, draw pipe, do the connection in between. So I will need to change elevation and go to 600. I go inside my mail stud, and I can do the same for the outlet of the receiver. Right click, draw pipe. And I will start my main header that will go to the main network. So elevation will be minus 1700. As I was saying, the network is going to be located at level 0, and right now we are at level 1. So for now, we've done the connection of both the compressor and the receiver, as you can see. And now we are only missing the bypass. So I will switch once again to my side view. And now I will convert this elbow in a T. So you can use, when you click on T's elbows across, you will have those little plus or minus appearing. And by clicking them, you will convert elbows in T's, T's in elbows, and so on. So I will be converting my elbow as a T. And then once again, I can start drawing the network. The routine preferences within the template will do the job and will provide me with elbows, automatic T creation, and so on, making things a lot easier to draw once everything is connected. Now we're only missing the valve. So Schroeder valve, we will find them once again, pipe accessories. Part number will be 4992, this one. I will choose the diameter 50, and I will directly plug my valve on my piping. So same, you've got that automatic grip activated, so everything will stick to the piping in a nice manner. If I switch back to the 3D overview, you can see the compressor room we just did. A compressor, a receiver, both connected, and a bypass on my receiver. As well for you to know, so here we are with threaded equipments. If you do have bigger equipment which have flange, they also have these parts. We have their flange, so you can also have them in pipe accessories. There will be part number RA30 and 31. Now let's continue to the main network. I will switch to my floor view of my main network. So compressor room has been done here, just above on level 1. We can see the beginning of our main header here, starting diameter 50. So to do the network, I will start where I finish with the compressor room. So I will start from the main header. I continue straight forward. So when it comes to main network, this would not be the hardest part, in my opinion, because it's going to be mostly length of piping to draw, and the routine preference will set everything, elbows and tees. When it comes to networks, usually the loop is going to be 1 diameter under the main header. So here we have a main header diameter 50. We're going to switch our main loop to diameter 40. So I change my diameter and I continue to draw my loop. So we can see the plugin reducer automatically added by the routine preferences, by the template. And I just continue to carry on and create the loop in between the pipes. If I switch to a 3D view of the area I'm working in right now, you can see the area where we are right now with the piping already drawn within the HVAC model. If we go here on the side, there is a little particularity here with that network. The sides are at a lower elevation than the main line. So here I am at 4,800 millimeters above level 1, above level 0. And here on the side, I will be at 4,500. So I will take it into account to draw my loop. Switch back to my ground view. Continue from where I stopped, draw pipe. I will change the elevation here within that green panel, 4,500, and then I'm continuing my network. And the routine preferences, same as you see, they will create everything automatically, so elbows, tees. I'm continuing to do my network. So here on that side, I'm getting back to 4,800. Coming here at the end, 4,500 once again, and then connecting here on the main header. Revit is calculating, and you can see the T automatically created. If I'm switching to the 3D overview, you can have a bit appreciation of what we did. So the main header coming from the compressor room, my reducing T, diameter 40, which go to one side of the loop, and my plugin reducer, diameter 40 as well, which go on the other side. Now a little side talk I would like to speak about before we are heading to the drops. It will concern error and mistakes detection within the template. Let's say I would like to create a line, diameter 63, which will plug inside my loop here. So I've got my line, diameter 63. I go to the loop. Revit is going to calculate and is going to give me a T. Whoops, this is wrong. 63, it works better. 63. I go on my loop. Revit is calculating, and Revit is going to provide us with a T, as it did before within the compressor room and the network. But when we have a closer look to that T, we can see something is kind of strange. There is some gap in between the T and the piping. The piping is on that side, literally going inside the T. So there is something wrong going with it. Why? Because that T, it does not exist within our range. This is a mistake that Revit did using the tables. So how to detect this mistake that can happen on the T on a rare occasion, because the T is the most complicated part? Well, two main methods. First method, if you switch to a 3D view, you can see those red circle appearing, those red warning sign. When you see them on your 3D view on some parts, it means there is something wrong with that part, and you need to manually apply a correction to restore and to have the proper part. So this is for the first method, red warning sign. Second method, will be to use the use of a shared parameter. So for you to know, each and every one of our families, they have a common shared parameter, which is called a product code that you will find within the identity data of each of our family. That product code, when it's right, it's gonna give you the part number of the family. So if I switch to the elbow here, you can see product code 6602 4000. So this is good, and the description going with it as well. When the fitting is wrong, there is something not right going with it. Both of these will give you a non-display, meaning there is something wrong going on. Knowing that, you can easily create a schedule, a quantity bill of quantities. I did set one already, and if you go on that list of quantities, you can see all the different parts we did design at the beginning. So diameter 50, so valve, elbows, and so on. And you can see here at the last line, so product code known, description known. You can see it's one quantity, diameter 40, and family and type a T. This is the T that Revit messed up creating. So this is a nice way when you are drawing some network to have a schedule set and to check on a regular basis if you have those non-products appearing and correct the mistakes right away. If I switch back to my main network, here's a problem. It's because the increasing T wants to do, it's too complicated. It needs to put several families on top of each other. It's too complicated for Revit to do. So what I would advise you to do is to simply cut the action you want to do in small pieces. So here, for example, first go from 63 to diameter 40. Revit will create the plugin reducer, and then from diameter 40 on one part, diameter 40 on the other one, and the equality will be properly created. Now, third and last part, drops. I will switch to the area we have right here as a 3D view, so with that pillar. You can see that pillar. When it comes to drop, two things to know. The mistakes we commonly see in model is the use of T when it comes to drop creation. So a drop, just to make it clear, so the drop is going to be the piece of pipe that is going to link your network, which is going to be next to the ceiling, to the point of view, which is going to be at the bottom. And because when it comes to compressed air, we can have condensate within the network, we don't use T's to create drops, but we use swan neck to do the connection. So on traditional network, we have swan neck made with T's and elbows, but when it comes to Trandair, we've got a piece that does its job already by itself. This is what we call a quick bracket with swan neck. So same in the pipe accessories. This is going to be part number 6662. And that quick bracket, if I put it here on the network and I'm zooming in, so you're going to have the connection from the side of the pipe. So you're going to have to drill a hole, and you can see the condensate is going to be retained at the bottom of the pipe, and the connection will be on the side. Meaning with one part, you can do this connection with a swan neck, and you don't need to use a tease with a bunch of elbows or to do any other configuration. First things to know, so when it comes to drop, use quick assembly brackets with a swan neck. Second things to know, I see it's already 30. I will try to make it quick. Wall brackets, you will have your point of views, and next to your point of views, you will mainly use wall brackets. These wall brackets, they are a family with hosts. So if I try to add them within my model, you will have that little block sign from Revit, which tells you there is no host valid. You can't put it there. If I put it next to that pillar, I've got a face valid, and I can apply my wall bracket next to it. So wall brackets, family with host. If you don't have any host valid, but you still want to use the wall bracket, one recommendation I will give you is to use what is called a reference plane. So you go in the architecture tab, reference plane here on the right. You create a reference plane, and that reference plane will be a valid host for your wall bracket here. You can see I can't put the wall bracket here in the area, but on the reference plan I can. And then you can move your reference plan to move your wall bracket. When it comes to the creation of drops, so same as a compressor room, in my opinion, the best thing is to first set your wall bracket and your quick assembly bracket with the swan net, and then to connect the both of them. So I've got my 2 wall brackets set. I'm gonna put my quick bracket with swan neck on my network. So I'm gonna automatically then put them on the network in front of my wall brackets. 1, 2, so I can also turn them if I need. I can turn them and so on. And then switch within a side view. You will have your bracket on one hand and your wall bracket on the other, and just to connect simply the 2 of them. So let's start from the wall bracket. Let's go up. I can use the adjust feature. Revit calculating, and the routine preferences are giving us the elbow, and we can do exactly the same here. We go up, we go under the piping, and we go straight inside our quick brackets. And there you have it. You have a completely done drop. If I switch to the 3D view, so we can see the drops here under. So we've got a really nice view. And if I switch to all the network that has been done already today, you can see, so the compressor room on one part, our main header, the loop, and our 2 drops. So I see that it's already 33, so that would be it for me. So thank you for your attention. So thanks for being with us today. And now, if you have any question, I will be more than happy to answer them.
Many thanks, Gael. It was clear, impressive demo. Indeed, we have a few questions. Feel free to ask more. I think the 2 questions are for you, Gael. The first one was, can you please show the first steps how to correctly upload families template to the Revit model?
Okay, so if you want to apply the template, I can't see the answer here. I'm missing. So how do you set inside the project the template? This is what.
How to correctly upload families template to Revit model. Okay,
so two ways to do it. First, you can create a new project. So new project. I'm gonna arrive here on this type there. So every project needs to have a template associated with it, and there you can browse. I'm gonna browse, and I can select my Tronder template. So let's say Revit database. And from there, up, okay, and Revit will just create you a new project with that template associated, and you will have access to all the families, to each and every one of them. So I hope it's not going to be too long. Second way you can do that is to, so this is in the, so there is some model upgrade. Okay, Revit is calculating. So as you can see, the template is available on Autodesk Revit 2018, so everyone is able to use it. Yeah, because I don't think there are Revit version used past before that now, or at least not much.
And you can download the last updated version of the Revit template with its Revit families on the BIM&CO.com website, which is, I guess, Gael updated from time to time. Hope it answered the question. Second question, interesting one, specific to the product itself. Do we need a flexible join between the compressor and the aluminum pipe? Okay, so okay, just to come back, so I will come back to the first question because the Revit is uploading the model. But when it comes to flexible, so this is a commonly asked question: do you need one? When it comes to our technology, so Tronder technology, it's not mandatory. Why? The use of
hose in between compressor and the piping is mostly when you have stainless steel networks. Stainless steel is really heavy compared to aluminum. It's actually 4 times heavier than aluminum. So when you have a connection in between a compressor and stainless steel equipment, you're going to be extremely heavy, and it's going to weight on the outlet of your compressor, which can be bad. This is why we're using flexible hoses on this type of connection. When it comes to us from there, we are in aluminum, so we are extremely light, and actually even lighter than if we were going to use hoses on the outlet of the compressor. That's why when you are using Trondair, you don't need actually hoses on the connection of your compressors. Aluminum is already so light, you don't need it.
Mm-hmm.
And also because we have our quick connection technology, we are not welded, so you're gonna have then the connectors, they have a bit of gap in between them, which help working that in case you would have vibration of the sort of thing. Our connection will take it without any problem. There are no aerial leak calculation. When it comes to pressure drop calculation, we've got a little program software that's called the Trondair Flow Calculator that we're using on the side to do that. So when you upload the template, to come back to the first question, you will have an example drawn already, as you can see. This is just an example to highlight the families and the usage. When you want to use a new project, just delete everything that it's within the example, and you can start fresh new. Otherwise, you can, of course, use within the insert tab, so insert, load family, and you can manually load the families. You can download from either the template or that you have downloaded on the BIM&CO's website.
Yes. With regards to the aerial calculation, if someone needs this information for this project, can they contact you, Gael?
Yes, of course. If you have technical question, compressed air project or natural gases project, you can contact us through there, and we can help you with all those sort of things. So sizing, designs, bill of quantities, etc., etc.
Great. Well, it's 40 already.
Yeah.
Is there any other question? Then many thanks for your participation. Thank you, Gael, for the live demo. It was really interesting. And we stay at your disposal in case you have any further question, or in case you want to dig in and discuss with Trondair or with BIM&CO on that topics. You will receive an email with, I believe, the video of the session if you want to see the replay. And well, have a nice day ahead.
Thank you very much for being here. Have a nice day.